Okay, Buddha. Now we can start today's theory lesson. In our previous class, you were given some homework regarding dimension analysis. Now we are discussing the application of dimension analysis. The first application was finding the accuracy of an equation. Then, now this is the second application. This is second application. Second application is determining the dimension of unknown physical quantity in an equation. So it is a something long analysis because when we are analyzing the dimensions, again the dimensions of it, analyze we have to consider several rules. Rules keep back and we have done about the rules, and so you are given some homework. අපි ඒ ටික කරපු නිසාම ඔයාලට homework එකක් දුන්නා වැඩේ කරන්න. හරිද මම හිතන්නේ අපි 14th question එක වෙනකන් අපි discuss කරා නෝ. We have done up to the question number 14. Have we done question number 15 and 16? 15 and 16. Have we done? Have we discussed? අපි කරානේ. Discuss කරානේ. Yeah, 15, 16 discuss kara. Now we have to discuss from 16 to 22, no? 16 to 22. Okay. 17 to 22. The question number 17, but the question number 17. The question number 17, y is equal log or LG A plus BP, capital A plus BP over V. Here, P is a pressure, V is a velocity. V is a pressure and V is a velocity. V is a velocity. Yeah, pressure, yeah, velocity. All right. Now tell me, what is the dimension of A? What is the dimension of A? Tell me. What is the dimension of A with the argument? With the argument.
1, because the inside function of a log is a number and the terms are added and subtracted, so it has same dimensions.
So what is the argument? You said the dimension of A is 1, no?
Yes, sir.
What is the argument for that one, Bhuta?
When the term is added or subtracted, it has similar or equal dimensions, right? So with that, we can say the inside function of the log is a number.
Okay. But the thing is, if look at this one. Now you are saying that argument. Previously you have said that thing also. All the terms in an equation should have same dimension. Okay. If you want to use that equation, at least you know the dimension of another term, no? Then A argument use කරන්න නම් අනිවාර්යයෙන්ම වෙන dimension වෙන term එකක dimension එකක් දැනගන්න ඕනේ. Okay? If you want to use that argument, actually you have to know the dimension of one term. Dimension of one term. Then you can equate that dimension with another term. Then you can say all the terms in an equation should have same dimension. That's why I equate these two dimensions. And have you equated? I equate kara?
Yeah, sir. I found that B also.
Huh?
By finding the B, I have equal down.
Previously you hari පුතේ hari. එහෙම කමන්නේ. Hari. The first thing the first you have found may be, no? So what is the argument that you have used to find B there?
The inside function of a log is a number.
Sorry?
The inside function of a log is a number.
Very good. That is correct. And okay, that is correct. That is correct. Totally correct. 100% correct. Yes, very good with it. So the inside a logarithm function, there should be a number. Therefore, A is a number, BP over V is a number. And that is the thing. Therefore, you can write this one. A plus BP over V is a number. It's a number. It's a number. Okay. Because because expression inside a log function. Expression inside a log function. Expression inside a log function is a number. Therefore, A plus BP over V is a number. Definitely, then you can write dimension of A should be equal to dimension of B into P over dimension of V is equal dimension of number. Because all the terms in an equation should have same dimension. That is the argument. Because all the terms in an equation should have same dimension. Should have same dimension. Now you know the correct argument now. So now you can equate these two and these two separately. These two and these two separately. Therefore, dimension of A is equal to 1 put A, and dimension of B into the dimension of pressure. Dimension of pressure means M L minus T minus 2 over dimension of velocity. Dimension of velocity is equal to LT minus 1 is equal to 1. Is equal to 1. Therefore, dimension of B is equal to then M minus 1 L to the power 2 T to the power 1. T to the power 1. Therefore, answer is M to the power minus 1 L squared T. Did you get my point?
Yes, sir.
Okay. Okay, very good, very good, very good. මේ හැම වෙලේම පුතේ මම හැමෝටම කියන්නේ මේ මොකද ආගියුමන්ට් එක ලියන්න කියලා සහ ආගියුමන්ට් එක හැම වෙලේම ආගියු කරන්න කියලා මම හැමදාම කියනවා වගේ හැබැයි ඒක සමහරලාට මේක මේ විදිහට ලියන්න ඕනේ නැහැ අතන මේක too much කියලා හිතෙන්න පුළුවන්. හරිද? ඒ වුණාට මට මේක හදාගන්න ඕනේ ඕගොල්ලන්ගම හදාගන්න ඕනේ මැකැනික්ස් කරනකොට පුතේ ආයේ මේ විදිහට කතන්දර කියලා හරියන්නේ නැහැ. මැකැනික්ස් කරනකොට පුතේ මාර ඩීප්ලි අපි යනවා. හරිද? එතකොට ඔයාලා හැදිලා ඉන්න ඕන. ආගියුමන්ට් වයිස් මේකක් හිතන්න. ආගියුමන්ට් වයිස් තියරි එකක් හිතන්න. ඔයාලා හැදිලා ඉන්න ඕන. හරිද? එතනට ගිහිල්ලා ඔයාලා අනර්ථ කරන්න බෑනේ. ඒක නිසා අනිවාර්යෙන් ඔයාලා මේ විදිහට උරු වෙන්න ඕනේ. ආගියුමන්ට් කර කරන්න ඕනේ. ඊළඟට මට මේ මතකයි කවුරුරි කාලා තිබ්බා මේ ට්‍රිගොනොමෙට්‍රික් ෆන්ක්ෂන්ස් ගැන මම ඒ ටික ආයෙසරක් ඔයගොල්ලන්ට කරනවා පුතේ. ඒ කියන්නේ ට්‍රිගොනොමෙට්‍රික් ෆන්ක්ෂන්ස් සයි කරනවා. මොකද මේක ඉංග්‍රීසි ගමන් ඊට පස්සේ මැකැනික්ස් කරනකොට අනිවාර්යෙන් මම එක්ස්ට්‍රා ටයිම් එකක් දාගන්නවා ට්‍රිගොනොමෙට්‍රි වලට. එක්ස්ට්‍රා ටයිම් එකක් දාගන්නවා කියලා කියන්නේ after this class we will do another class. Regarding trigonometry as well as basic mathematics. Okay. Alright. But if you want to watch the previous recordings of my previous years, please let me know. Then I will send those recordings. If you want to watch them, that means if you want to watch the basic mathematics recordings in previous years, please let me know. Then I will share the recordings. කවුරු මතක් කරලා මට පොඩ්ඩක් ඒක ආයෙත් මතක් කරන්න මම එවන්නම්. අවශ්‍ය කෙනෙක් ඉන්නවා නම්. හැබැයි ඔයගොල්ලන්ට මම ආයෙත් එක කරනවා. ඒක වෙනම ඩේ එකක් මම දානවා ඒකට. හරිද? වෙනම ඩේ එකක් දාලා වෙනම ඔයගොල්ලන්ට එක තියෙනවා before the mechanics. හරි? Okay. Then the next question. Eighteenth one. 18th one. Y is equal log 10 a squared x plus bt. A and B, sorry, x is displacement. X is displacement, t is time. T is time. Okay. Now tell me what is the dimension of x and t, x and b. Sorry, A and B. What are the dimension of A and B? What are the dimension of A and B?
B equal t minus 1. Sir.
Very good, Pute. Your correct is, as is correct.
And a equal L minus 1 to root to the power root of.
Okay. Yes, very good. So what is the argument? It is the same argument. No, it is the same argument. There should be a number inside a logarithm function. So based on that argument, a squared x plus dt should be a number. It should be a number. What is the argument? Argument is there should be a number inside a logarithm function. There should be a number inside a logarithm function. That is the argument. That means dimension of a to the power is a to the power 2 and dimension of x is equal dimension of b into dimension of t is equal dimension of number, that is 1. Okay. Or now the argument for this step is all the terms in an equation should have same dimension. That is the argument for that step. Okay. Therefore, it is very clear B is equal the dimension of B is equal t minus 1 then dimension of A square is equal L minus 1. So you have to take the square root of both sides, then dimension of A. Then the dimension of A is equal L to the power minus half. Taking square root means taking half power. Half power. L to the power minus 2. Minus half. Now tell me, what is the dimension of y? What is the dimension of y? Take an additional question. Write this one as an additional question to the question number 18. To the question number 18, write this one as an additional question. Determine the dimension of y. Determine the dimension of y. Yes. Very good. Very plus 9. Very good. That is equal to 1. No, that is equal to 1 because y is equal to a logarithm function. Logarithm function doesn't have a dimension. Therefore, dimension of y should be equal to 1 or it doesn't have dimension. Okay. So when you are writing this one as an essay question, don't stop after 1. 1 stop කරන්න එපා. Right? No dimension. No dimension කියලා ලියන්න. හරිද? No dimension කියලා ලියන්න. මොකද සමහර කෙනෙක් කෝක 1 කියලා දැම්මොත් තේරෙන ඩොන් ගාලා අය මෙතනින් නැවතුයි කියලා අහන්න පුළුවන්. හරි? මේ දැන් මේ කැල්කියුලේෂන් පුතේ කැල්කියුලේෂන් වලදී මට no dimension කියලා දාලා කැල්කියුලේට් කරගෙන ඉන්න බෑ. ඒ නිසා කැල්කියුලේෂන් වලදී when you are doing calculation you have to use 1. Okay? Otherwise we can use a word no. But as an answer, as a essay answer, don't stop at 1. Write in the word that y doesn't have dimension. Y doesn't have dimension. Oh, no dimension. Eh? Then 19th one. What is the answer for 19th one? They are lazy. 19th one?
A is equal L and dimension of B is equal T minus 1.
Very good. Okay. When you are deriving the dimension of B, what was your argument, Pute? What was your argument?
There should be an angle inside the trigonometric function.
Yeah. And angle doesn't have a dimension. Very good. Very good. I think. Then the 19th one, sine A is equal sine BT is equal A sine BT. Therefore, definitely, this one is equal to an angle. This one is equal to an angle. So BT is an angle. Angle doesn't have a dimension. Therefore, dimension of B into dimension of T is equal dimension of angle, that is equal 1. Reason is angle doesn't have a dimension. That is the argument. Angle doesn't have a dimension. Okay. That is the argument. So using that argument, I can write the dimension of B is T minus 1. Now tell me, what is the argument that you have used to determine the dimension of A? Again. What is the argument that you have used to determine the dimension of A?
Because sine BT is a trig function with an angle and then it doesn't have any dimension, then therefore dimension of A is equal to S, dimension of S.
Now, actually, now we don't want to consider about angle. Yeah. Because sine BT is a trigonometric function. Sine BT is a trigonometric function. S is equal A sine BT. Okay, A sine BT. This one, the entire function is a trigonometric function. It's a trigonometric function. Trigonometric function. Therefore, it doesn't have a dimension. It doesn't have a dimension. Therefore, it doesn't have a dimension. Trigonometric functions doesn't have a dimension. It doesn't have a dimension. ඒක හරියට ලියා ගන්න පුතේ. ඒක හරියට ලියා ගන්න. හරිද? මේ මම මේක A වල කොහොමද ගන්නෙ? A වල ගන්න ආගියුමන්ට් එක තමයි පුතේ A වලින් මේ පැත්තට trig function එක it doesn't have a dimension. It doesn't have a dimension. This one doesn't have a dimension. So that means the dimension of this part can be considered as 1. 1. Therefore, dimension of S is equal to dimension of A into 1. Into 1. Therefore, dimension of A is equal dimension of S, that is A L L. Therefore, dimension of A is equal to and you have to write the correct argument. 100% correct argument. You have to write the 100% correct argument. घर मत दिया करना. Okay. Okay. Actually, when you are studying, I think it is the best way is teaching. The best way is teaching. You have to teach what you want to learn to someone. To someone means it may be virtual, it may be a virtual student. And what you have to teach. It is very good to learn. And අනිවාර්ය මතක තියාගන්න අපි ටීච් කරනවා නම් අපි මොකක් හරි දෙයක් ටීච් කරනවා නම් පුතේ මාරම ලේසි පුතේ ඒක අන්ඩර්ස්ටෑන්ඩ් කරගන්න. මොකද මට ඔයාලට යමක් කියා දෙන්න බෑනේ පුතේ මම දන්නේ නැතුව. එහෙම වුණොත් මට නිකන් ඔහි කියන්න පුළුවන් අන්තිමට මොකක් හරි ඒ කියන්නේ ආගියුමන්ට් එකක් මට බිල්ඩ් කරන්න බෑනේ. ආගියුමන්ට් එක බිල්ඩ් කරනවා නම් බිල්ඩ් කරන්න පුළුවන් මම හරිම ආගියුමන්ට් එක දන්නවා නම් විතරයි. හරිම ආගියුමන්ට් එක මම දන්නේ නැත්නම් මට ආගියුමන්ට් එක බිල්ඩ් කරන්න බෑ. ඔහි මොකක් හරි කියන්න පුළුවන්. අර කට ගන්නවා වගේ නිකන් කියුම් යන්න පුළුවන් පොඩ්ඩක් ඕන මොකක් ජෝක් එකක් කරලා එහෙම යන්න පුළුවන්. එහෙම නෙවෙයි. ආගියුමන්ට් වයිස් යමක් එක්ස්ප්ලেইন කරනවා නම් අනිවාර්යයෙන්ම ආගියුමන්ට් එක දැනගන්න ඕනේ. හරි ආගියුමන්ට් වයිස් යමක් එක්ස්ප්ලেইন කරනවා නම් අනිවාර්යයෙන්ම ආගියුමන්ට් එක දැනගන්න. මේක නිසා හැම වෙලේම යූස් කරන්නේ ටීචින් මෙතඩ් එක. වා කාටරි ටීච් කරන්න හැම වෙලේම. ඒ ටීච් කරනකොට පුතේ නිකන් ටීච් කරන්න බෑ වාට. වාට ටීච් කරනවා ඔන්නවා හිර වෙනවා. හිර වෙනකොට තේරුම් ගන්න ඕනේ හරි. මට මෙතන මොකක් හරි කොස්සක් තියෙනවා. මම මොකක් හරි ආගියුමන්ට් එක මම ආයෙත් මොකක් හරි බලා ගන්නවා. හරි ඔන්න එන ඔයාගේ අර ඇඟ ඇතුලේ තියෙන අර මේ මිස්ටේක්ස් එළියට. හරි මාර ලේසි එතකොට වැරදි හදාගන්න. මම ගොඩාක්ම යූස් කරේ මම එල් කරන කාලේ ටීචින් මෙතඩ් එකමයි. ඒකම තමයි අන්තිමට මට මේ වෙයි ටීචින් වලට මට යූස් උනේ. I think අරක ඒ විදිහට හුරු වෙලා ඉතින් මට ඔටෝමැටිකලිම ඊට පස්සේ ඇඟටම ආවා. හරි. ඒ නිසා ඒ ටීචින් මෙතඩ් එක මාරම ඉෆෙක්ටිව් මම. ඒ ඉගෙන ගන්න පොඩ්ඩක් හරියට ඉගෙන ගන්න. හරි. අහලපු දෙයක් ඕනේ ඉගෙන ගන්න පොඩ්ඩක් මාර ඉෆෙක්ටිව් විදිහට ඉගෙන ගන්න පුළුවන්. හරි. ඒ නිසා මේ පොඩ්ඩක් ඔයගොල්ලෝ යූස් කරන්න. අන්න ඒකවල. ටෙඩි බියර්. ටෙඩි බියර් කෙනෙක් යූස් කරන්න. හරි. වඩා හොඳයි දැන් අර ඉන්නවනේ අපි අර කතා කරනකොට අර එයා රෙකෝඩ් වෙලා ආයෙ පාරක් රිපීට් කරන ටෙඩි බියර්ස්ලා ඉන්නවනේ. අන්න ඒ වගේ අල්ලගන්න. වඩා හොඳයි. Okay. Right. Then the 20th one, බලන්න. Y equal A sine, Y equal A sine within the square root K over B into T. Into T. Y is a displacement. Make a displacement. Make a displacement පුතේ. T is a time. T is a time. Comma. K is spring constant. K is spring constant. Spring constant. T is T. Time. T is time. Okay. So what is the meaning of spring constant? What is the meaning of spring constant? It is something like this. It is something like this. Okay. Suppose there's an elastic body click and me on. Other 2025 කට්ටියගේ unit එක spring constant එකේ පාරේ. ඒ නිසා elastic rubber band එකක් තියාගත්ත ළඟපාත elastic body එකක් පේනවා. So this one can be considered an elastic body. Okay, elastic. Elasticity means suppose if I apply a force, if I apply a force on this object, it will be deformed. It will be deformed. Once I release this force, what will happen? The object become to its original shape and size. The object will become to its original shape and size. Once I apply a force, the object will be deformed. It will be deformed. Once I release that one, it comes to the original shape and size. That property is called as elasticity. That property is called as elasticity. Okay. So if I apply a force, if I apply a force, this will be deformed. So if you want to get more deformation, you have to apply a more force. Okay. Therefore, if I apply a force, on this kind of elastic body, this one will be stretched, no? This one will be stretched. That stretched length is called as elongation. This stretched length is called as elongation. Normally, it is represented by E. Suppose I apply F force here. So there's a relationship between F and E. What is that relationship? F is equal to K into X, K into E. And F is equal to K into E. K into E means K means so if I apply more force, if I apply a more force, that means higher force, I can get higher deformation. high deformation. Therefore, I can write this thing F directly proportional to E. Once F is increases, E also increases. Definition therefore, this relationship can be converted into an equation. So this one can be written as this. Okay. So this is the relationship between F and E. F and E. Okay. So this one is called as spring constant. Spring constant. So spring constant depends on the material put. Some material are very easy to deform, but some material are really hard to deform. Can you deform this pen? Can you deform this pen using a force? No, it is very hard. But you can deform this rubber band. No? You can deform this band. It is very easy. Therefore, some materials are very easy to deform, while the others are very hard. So that depends on this value, K value. K value is called as spring constant of a material. Spring constant of a material. Therefore, spring constant is equal to K F over E. F over E. Therefore, dimension of the spring constant. So, what is the dimension of the spring constant? This is M L T minus 2. Elongation means a length, no pute. It is a length. Therefore, it is a length. It is a length. No pute. Surface tension is something different than that. Okay. It is totally different physical quantity.
So then,
Sorry?
so then the strain mean what?
Sorry?
So then strain mean what?
Strain.
Yes.
So this is not strain. Strain and there's another equation. So this is called as one-dimensional Hooke's equation. In this equation, Hooke's means scientist. He considered only the deformation, only the linear deformation. That means length only. And මෙතන හුක්ස් කියන එක කෙනා යූස් කරේ පුතේ මේ එයා හිතුවේ length එක විතරයි කියලා මුලින්. ඒ නිසා අපි මේක කියනවා one dimensional Hooke's law කියලා. හරිද? ඒ වුණා ඇත්තටම මෙහෙම length එක විතරක් deform වෙන්නේ නැහැනේ. දැන් මම මෙයාව අදිනකොට මොකද වෙන්නේ? මෙයාගේ volume එක වෙනස් වෙන්නේ නැහැනේ. මම මෙයාව අදින්න මොකද වෙන්නේ? මෙයාගේ cross sectional area එක අඩු වෙන්න ඕන. cross sectional area එක අඩු වෙන්න ඕන. හරි? අපි අර cleverin 9 හදන්නේ. Cleverin 9 හදන්නේ මොකද වෙන්නේ? අපි length එක වැඩි කරන්න මොකද වෙන්නේ? cross sectional area එක අඩු වෙනවා. cross sectional area එක අඩු වෙනවා. හරි? මෙයාගේ දිග වැඩි වෙන්න cross sectional area එක අඩු වෙනවා. හරි? ඒ වගේ තමයි අනිවාර්යයෙන් අපි මේක deform කරනකොට පුතේ cross sectional area එක හැම consider කරන්න ඕන. හරිද? ඒක ඊට පස්සේ initial length එක. හරිද? දැන් අපි ගත්තොත් එහෙම අර චූටි ලණුවක් ගත්තොත් එහෙම චූටි ලණුවක් අදින්න අමාරුයි. හරිද? දැන් මේ රබර් බෑන්ඩ් එක අදින්න ලේසි පුතේ. හැබැයි මම මෙයාව කඩලා පොඩි කැල්ලක් ගත්තොත් ඒක අදින්න අමාරුයි. හරිද? ඒ නිසා length එකත් initial length එකත් ඔකට බලපාන. හරිද? ඒ නිසා මේක අපිට මේ one dimensional එකකින් විතරක් කියන්න බෑ. ඒ නිසා ඊට පස්සේ මේ හුක්ස්ම තමයි ඊට පස්සේ මේක additionally අර the fundamental equations of elasticity කියලා equation එකක් මම derive කරා. අන්න එතනදී අපිට ආවා stress strain කියන relationship එක. Okay. So this is not the relationship between stress and strain. This is the one-dimensional Hooke's law. There is one-dimensional Hooke's law. So in one-dimensional Hooke's law, there's a constant that is called as spring constant. Okay. So there's another concept that is called as the fundamental equations of elasticity. It is also a Hooke's law, another Hooke's law. In that case, Hooke's may consider not only about the elongation of length, but also the area and the initial length. Okay. So in that case, there is a relationship between stress and strain. Stress and strain. Okay. ඒක පස්සේ දැන් ඔයගොල්ලන්ට වැඩි. හරි දැන් ඔයගොල්ලන්ට වැඩි. නමුත් මේක පොඩ්ඩක් අන්ඩර්ස්ටෑන්ඩ් කරගන්න K කියන්නේ මොකක්ද කියලා මේ ටික. හරි. So L to L will be cancelled out. So dimension of K is equal mt minus 2, mt minus 2. That is the dimension of K. Okay. Right. So this is about Hooke's law. Okay. This is about Hooke's law. One-dimensional Hooke's law. Okay. Normally we call it as one-dimensional Hooke's law. One-dimensional Hooke's law. Now we make it here. Stress and strain means another thing, okay? Stress and strain means another thing. It is connected using this equation. F over A is equal y into E over L. So this is the force, this is the cross-section area, this is the elongation, this one is the initial length. This y is called as Young's modulus. Young's modulus. And Young's modulus collective. එතනදී පුතේ මේ තියෙන්නේ stress එක, මේ තියෙන්නේ strain එක. This one is stress. This one is strain. This one is strain. එක දෙකක් නේ. This one strain means E over L. Stress means F over A. F over A. Right? So those two are two different equations, but actually they have used to express some kind of equal scenarios, but in two different ways. In this case, Hooke's doesn't consider about the area and the initial length, but in this case, this considers. Right? මේක එච්චර ඔල්ල ගන්න එපා. මේක එච්චර ඔල්ල ගන්න එපා කියලා මට මෙන්න මේක විතරක් වගේ ඔළුව තියලා නම් ඇති. මොකද්ද මේ ස්ප්‍රින් කාන්ස්ටන්ට් එක කියලා කියන්නේ කියලා. ඕන මේක දාගන්න. As a note, as a special note ඕක මේක දාගන්න. අර එකපාරට අර කඩපාඩම් කරලා මතක තියාගන්නවට වඩා ලේසි මොකද්ද මේ කියන්නේ කියලා කිව්වොත් ඒකයි මම කිව්වේ. මේ ගැන එහෙම ඔළුවට යන්න නැත්තම් try කරන්න එපා දාගන්න. කාලේ එනවා. ඉස්සරහට නියම ඔබ ඔළුවට යනවා. හරි. හරිද? Okay. Okay, do I this one? Now tell me. So what is the easiest physical quantity that can be determined? What is the easiest physical quantity? A or B? A. So what is the argument? What is the argument?
Trigonometric function does not have a dimension.
Yes, very good. Very good. Very good. Very good. Trigonometric function doesn't have a dimension. Therefore, dimension of A is equal to dimension of Y. Dimension of A is equal to dimension of Y. So dimension of A is equal to L. No, dimension of A is equal to A. මම ආයෙ එක ලියන්න යන්නේ නැහැ. අර අසලක එක ලියන්න යන්නේ නැහැ වෙන දෙයක්. ඊළඟට මේක. දැන් මොකද කියන්නේ? The entire thing, that means square root k over b into t. The entire thing is an angle. Is an angle. The entire thing. Therefore, square root k over b into time is an angle. As an angle. Therefore, dimension of this one into dimension of this one is equal to the dimension of angle. Is equal to dimension of angle. Therefore, square root means half pound, half the pound. Therefore, k to the power half, k to the power half over b to the power half is equal t minus 1. T minus 1 is equal to t minus 1. Right, may I t minus 1. You can take t here. That means it will become t minus 1. Now this is half. Power is half, no? So if you want to may convert it into the first power, what should I do? මම මොකද කරන්න ඕනේ? මෙයා එක කරගන්න. I have to take the square, no? I have to take the square. Yes, I have to take the square of both sides. I have to take the square of both sides. So if I take the square of this one, the dimension of k is equal to dimension of b is equal t to the power minus 2. T to the power minus 2. I have to take the square of both sides. I have to take the square of both sides. Then dimension of b is equal dimension of k. Dimension of k means m t minus 2. That is the dimension of k over t minus 2. T minus 2. Therefore, t minus 2 to t minus 2 will be cancelled out. Dimension of m, dimension of b is equal to dimension of b is equal to m, not m square. Only m square නෙමෙයි. මෙයා square වෙන්නේ නැහැ. මෙයා තායිසල බීමුනේ. තේරුණාද? Did you get my calculation here? Did you get my calculation?
Yes, sir.
Thank you, Uday.
Yes, sir.
Thank you, thank you. Very good. The next question. Shall I erase this one? I'll make a mark under there. Shall I erase the board today?
Done, sir.
Thank you.
Okay, sir.
Thank you. First, 21. V is equal AW cos BT. V is equal A omega cos BT. Cos BT. A omega cos BT. V is the linear velocity, omega is the angular velocity. It is given. This is linear velocity. This is the angular velocity. Okay. Now it is given V is equal A omega cos BT. A omega cos BT. In here, V is the linear velocity. Omega is the angular velocity. Omega. Now, how to find the dimension of A and B? A and B. Type down here. Take a basic. So, what is the dimension of A and what is the dimension of B?
A equal L, sir. B equal T minus 1.
B equal T minus 1. A equal
L.
L. No, correct. Very good. Look at this one. I can take this one. B into T. You know, the inside a trigonometric function, there should be an angle. So based on that argument, I can write BT. BT is an angle. It's an angle. So what is the argument? Inside a trigonometric function, there should be an angle. There should be an angle. So definitely, angle doesn't have a dimension. Therefore, dimension of that one is equal to 1. Then dimension of B is equal to T to the power minus 1. T to the power minus 1. Then again this one. A into omega is equal dimension of V. Cos omega text. What is the argument based on this? What is the argument?
Because cos BT is a trig function.
Yes, very good. Because cos BT is a trigonometric function and trigonometric function doesn't have a dimension. Find that term. A trigonometric function doesn't have a dimension. So this one, A omega should be equal, dimension of A omega should be equal dimension of V. Dimension of V. I'm not writing again. Oh no, yeah. Because trig function doesn't have a dimension. Doesn't have a dimension. Okay, then dimension of A, dimension of omega. What is the dimension of omega? Angular momentum. What is the dimension of angular momentum?
T
Angular
minus 1.
momentum. Sorry?
T minus 1.
Yes, very good. With T minus 1, it should be T minus 1. Dimension of velocity is equal to L T minus 1. Therefore, T minus 1 to T minus 1 will be cancelled out. So, dimension of A is equal to A. Dimension of A is equal to L. Is equal to dimension of A is equal to L. Correct. I will be like last one. Last one. Is equal half n omega square A square sin square dt dt plus C. E is the energy. E is energy. M is mass. E is energy. This one is mass. Angular velocity. Angular velocity. And T is time. T is time. T is time. Now tell me. You can use the same arguments. Now tell me. What is the dimension of A, B, and C?
A equal L, sir. B equal T minus 1. C equal 1.
Wherever. Others are the A is equal L, B is equal T minus 1, and C is equals 1. And already. We can use the same argument here, Putte. We can use the same argument. Look at this one. This one, BT plus C, definitely should be an angle because inside a trigonometric function, although it is a square, the inside trigonometric function there should be an angle. There should be an angle. Therefore, based on that argument, BT plus C should be an angle. Should be an angle. Because inside a trigonometric function there should be an angle. Therefore, there should be an angle inside a trig function. Inside a trig function. So This one should be an angle, BT should be an angle, C should be an angle, because all the terms in an equation should have same dimension. Therefore, BT should be equal to the dimension of C and should be equal to the dimension of angle. This one. So what is the reason for this one? What is the reason for this one? All the terms in an equation should have same dimension. That is the reason. All the terms in an equation should have same dimension. Should have same dimension. Should have same dimension. That is the argument for this one. So from that, I can say dimension of B should be equal to E minus 1, and dimension of C should be equal to angle, that is 1. That is no dimension. No dimension. Then this part, මොකද වෙන්නේ? The entire thing, that means m omega squared a squared, the entire thing should be equal to the dimension of energy, because trigonometric function doesn't have a dimension. Trigonometric function doesn't have a dimension. Therefore, this one should be equal to E. I got diagram. And a dimension of E is equal dimension of m into dimension of omega square into dimension of a square, because trigonometric function doesn't have a dimension. Trigonometric function doesn't have a dimension. So dimension of E. What is the dimension of E? Tagaken energy ke dimension what?
ml square t minus 2.
Very good, very good. M L squared t minus 2 is equal, dimension of m is m, dimension of omega is t minus 2, t minus 2 into 2, again t minus 2. T minus 1, t minus 1 into the power 2 is t minus 2. This is a square. Therefore, m12 will be cancelled out, t minus 2 will be cancelled out. Therefore, a squared is equal L squared. Dimension of a squared is equal L squared. So, dimension of A is equal, yes. Dimension of A is equal 12. And sorry. තේරුණාද?
Yes, sir.
Okay. Now, so this is the end of dimensional analysis, the second part. This is the end of second part. That means second application. Now, what is the second application? Determine the dimension of an unknown physical quantity. මම හිතන්නේ ඒක ඔයගොල්ලෝ හොඳටම කරා. ගොඩක් හොඳයි ඒක. හොඳටම ආන්සර්ස් දුන්නා. ඒ නිසා මට ඒක ගැන සැටිස්ෆයි වෙන්න පුළුවන් ඔයගොල්ලෝ හොඳටම ග්‍රැප් කරා කියලා ඒ theory part ටික. හරි. Now we are going to next theory part. And before that one, we have to take a break. Otherwise, we will to look at navigate. And break at the okay, now it is about 10:25. You can take 20 minutes break and please come. So not 10, 4. 4:50, for 4:45. 4:45 we're not got and අලුත් ලෙසන් එකක් යන අලුත් ලෙසන් එකක් කියන්නේ ටිකක් ඒ කියන්නේ හරියට තේරුම් ගන්න ඕන ලෙසන් එකක් යන්නේ. හරි. හරියට 4:45 වෙනකොට එන්න. හරි. Okay. Now you can take a break, okay? Okay. Welcome back, guys. Okay. Now we can discuss our next lesson. Next lesson means the next application. Now we have done two applications. First one is applications of dimension analysis. The first application is determine the accuracy of an equation. Then the second application is determining the dimension of an unknown physical quantity in an equation. Those are the two applications that we have discussed up to now. Then the third application is determining the unit of determining the unit of an unknown physical quantity, an unknown physical quantity, determine the unit of an unknown physical quantity. So this is the third application. This is the third application of dimensional analysis. This is the third application of dimensional analysis. This is very easy, Pute. This is very easy because in an equation, now we can determine the dimension of an unknown physical quantity. Okay. Suppose you are given this kind of equation, F equal m is a. So we can determine the dimension of this unknown factor, unknown physical quantity. Therefore, dimension of Z is equal MLT minus 2 over M. That means LT minus 2. Once you determine the dimension, then you can assign the SI unit of M, L, and T. M, L, and T here. It's very easy. You can assign the dimension of, the unit of M. Unit of M means unit of L. The SI unit of L means meter. Then you can assign the SI unit of T. That is second. Therefore, unit of SA is equal MS minus 2. MS minus 2. MS minus 2. Okay. So this is very easy one. You just need to determine the dimension first. That is must. You have to determine the dimension. Then you can apply the SI unit of M, L, and T instead of dimensional equation, dimensional formula. Did you get my point? Dimension එක හොයන්න dimension එක හොයලා ඒකේ M L T වෙනුවට කිලෝග්‍රෑම් මීටර් සෙකන්ඩ් ගන්න. එච්චර. පැහැදිලිද පුතේ? Clear?
Yes.
So in this case, then we have to remember two things. The first thing is from this method we can determine only the derived form of SI unit, not the SI unit. This is the derived form. In this case, this is equal to SI unit 2. But using this method, we can determine the derived format of the SI unit. Okay. All right. And other thing is, if there is an angle or angular formula, we cannot determine the SI unit using this dimensional analysis. And angle at the book with the dimensional analysis unit gonna be. As an example, suppose AC equal R theta. AC equal R, yeah. Suppose VC equal A sin, sorry, VC equal A sin theta. 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 VC e S is equal A sine omega t. Solve this one. S is equal A sine omega t. S is a displacement. Let me tell you. A sine Vt. A sine Vt. S is equal A sine Vt. Suppose you are given to determine the SI unit of B. SI unit of B. So it is very clear. It is very clear. Dimension of B. Dimension of B is equal T minus 2. T minus 1. T minus 1. T minus 1. It is very clear. Dimension of Bt. Dimension of B. Dimension of B is equal T minus 1. Is that clear? Then this one. Dimension of B is equal to T minus 1. It is clear?
Yes.
Because BT is an angle, BT is an angle, therefore the dimension should be equal to 1. So dimension of B should be equal to T minus 1. So if you assign now if you use the same method, use color, then the dimension, then the unit of B can be written as S minus 1. Can be written as S minus 1. And because instead of T, I can write S. And but the thing is, if I write something like this, it will be wrong. It will be wrong because this is an angle. This is an angle. So although the angle doesn't have a dimension, it has a unit. It has a unit. It has a unit. Therefore, you have to consider that thing. Therefore, if there is this kind of case, that means if there is an angle, so this is for angles only, Pute. Angles so if there is an angle, the angle both, we cannot use the same method. So we cannot use the dimensional analysis. Therefore, if there is an angle, then you can just simply apply the units of others. So make angle like, so this one is angle. So angle is where the angle is measured by radian. It is measured by radian. Therefore, B is equal radian per second. Radian per second. Radian per second. Make angle like that. This one is measured by second monitor product. Therefore, B into seconds is equal radian. This is measured by second. This one is measured by second. Therefore, B is equal radian per second. මතක තියාගන්න අපිට angle එකක් આવොත් මට මේ dimension analysis එකෙන් හොයන්න බෑ angle එකක් આવොත්. හරිද? angle එකක් આવොත් අනිවාර්යෙන් මෙහෙම තමයි හොයන්න වෙන්නේ. ඒ කියන්නේ angle එකේ definition එකට යන්න වෙන්නේ. හරිද? ඒ අරුණාම මට dimension analysis එකෙන් මට unit එකක් හොයන්න පුළුවන්. Okay, did you get my point? Clear?
Yes, sir.
Okay, they write the topic. They write the topic. They write the topic. Determine the unit of an unknown physical quantity. Write down this. Write down this. In this case, the dimensions of the dimensions of in this case the dimensions of the unknown physical quantity, the unknown physical quantity should be determined first. Then the signs of M, L, and T are assigned to the dimensional formula. Make it right. Don't write this one. Only this. Correct. Okay. Write down under this. This method cannot be used when there is an angle. In such cases, we have to follow the below method. Now you can write this one and this two.
Sir, what do you say? We have to follow the
below method. Once you complete writing, you have to copy down this, okay? Copy down this from here to here. Okay, from which point, Pute? From which point? From which point in honors possible? After the first example, no? But this method cannot be used for angles. Okay? Can anyone repeat the sentence? Can anyone repeat the sentence?
So
Yeah.
this method can be used when there is an angle. In
This
such
method
cases,
cannot be used. Okay? This method cannot be used.
can be used when there's an angle. In such cases, we can use the below method.
That's right. This method cannot be used. This method cannot be used when there is an angle. When there is an angle. In such cases, in such cases, we have to follow the below method. We have to follow the below method. Try this one. We have to follow the below method. Okay. That is very easy application. No need to do for the examples, because once you determine the dimensional formula, you just need to apply the units. Okay. Then write the fourth application. Write the fourth application. Yeah, what duck? Important application. Write the application. Fourth application. Fourth application of dimensional analysis. Building a relationship. Relationship means, in this case, it is a formula. Building a formula between the given physical quantities, between the given physical quantities, building a relationship within bracket formula. In this case, I'm talking about formula between the given physical quantities. Sorry, building. L is missing. Right. Thank you. Building a relationship between the given physical quantities. එන්න මේක පොඩ්ඩක් හරියට අඳුර ගන්න ඕන. So, හැමෝම අහගන්න. Okay, please listen to me very carefully, everyone. Stop your work and listen to me very carefully. Very carefully. So, as the second example, as the second application, this one also a very logical application. Very logical application. You have to build an argument and do the work. Okay, so this one also a logical application. Look at this one. Now we are going to build a relationship between some two or more than two physical quantities. Okay, as an example, suppose you are given force, mass, and area, acceleration. Force, mass, and acceleration. Suppose you are given these three physical quantities. And you are asked to build a relationship between these three physical quantities. You know F is equal ma. You know that thing. But think as Newton. Newton is the at the beginning of the Newton's era, he did not about that thing. So he had to prove that equation. No? Something like that. And now there are three physical quantities, and you have to build a relationship between those. Build a relationship and as well as a formula. Not only a relationship as well as a formula. I have to build a formula connecting those physical quantities. How to do that? There are a lot of methods, but dimensional analysis can be used to determine up to some extent. Okay, so dimensional analysis can be used to determine such kind of relationship up to some extent. Example of dimensional analysis use කරන්න පුළුවන් ඒ වගේ formula එකක් build කරන්න. හැබැයි there are some limitations. There are some limitations. So that's why I use that word up to some extent. Therefore, dimensional analysis can be used to derive such kind of formulas up to some extent. How to do that? How to do that? Before learning about this thing, we have to learn about two relationships between physical quantities. So what are the relationships between physical quantities? We have to be aware about that. In that case, we are going to discuss about two main relationships between two physical quantities. One, then අපි යන්න පුතේ physical quantity දෙකක් අතර තියෙන relationships මොනවද කියලා බලන්න. Now we are going to check what are the relationships available in two physical quantities. හරිද? බලමු මොනවද කියලා. The first relationship is directly proportionality. Directly proportionality. I know you know this thing. Directly proportionality. Suppose there are two physical quantities x and y. The first relationship means directly proportionality. So what does that mean? මොකක්ද directly proportionality කියලා කිව්වේ? What is about directly proportionality? What is the definition of directly proportionality?
If one increase, another quantity also will increase according to the same one.
Any other alternative suggestions? Okay, according to Masha's definition, I will write this only. 1, 2, 3, 4, 5, 6. 1, 2, 3, 6. Now there are two cases. There are two cases. In both cases, when x increases, y also increases. No, when x increases, y also increases. Are they both directly proportional or not? Then now directly proportional. Then suppose this one case 1, this one case 2. Case 1 and 2 both are directly proportional or not. One second one.
Both are
No.
So the first one is directly proportional and the next one is not.
No.
Because it increased by the same quantity and other one increased with different quantities.
This one is the directly proportional one. This is not. This is not. And look at the. That is the thing. You don't know the definition of directly proportionality. And what is the meaning of indirectly proportionality? What is the meaning of indirectly proportionality? But you had a lesson, no? You had a lesson in grade 11 and 11 or 10. Indirectly proportionality. I think there are a lot of problem in my oral paper. Indirectly proportionality. What is the meaning of indirectly proportionality? Tell me.
If one quantity increase, other quantity decrease.
Other quantity decrease. Then x, y. 1, 2, 3, 4. Sorry. 3, 2, 1. 3, 2. Okay, this is another case. This is third one. Fourth one. X, y. 5, 10, 15. 5 to 10. 10 to 5, 25.
the ratios of the two is equal to a constant value. That means the real
I cannot hear you, Bhute. In both case, when x increases, y decreases. When x increases, y decreases. Are they both indirectly proportional or not?
Indirectly proportional.
Okay. The problem is you don't know the exact definition. And මම මේ question එක පුතේ හැමදාම oral කරලා ඉවර කරලා වගේ අහනවා. හරිද? ඔය problem එක තියෙනවා. So that is the difference between oral and error. And actually I know you have done this unit very well. No? I think indirect proportionality is a very simple unit for you, no? Well, it's very simple unit for you. But the thing is, even though you you can calculate those questions. You cannot understand definition. And මේක ප්‍රශ්නේ. හරි. හරි. ඒක නෑ ඒක දැන් මුත් කියන්නේ මොකද මුත් කියන්නේ මොකද ඕනේ කියන්නේ එහෙමනේ පුතේ ඕක මේ ඕගොල්ලෝගේ ඒක බලන්නේ නැහැ. හරි. But now it now this one is zero. Okay. Now this is a different. Okay. Now this is different. Okay. We cannot go further without understanding the definition, and we cannot go further without understanding the theory part very well. And මේක කිව්වට ඉතින් මේක දැන් ඔය වෙන ළමෙක්ගෙන් අහුවත් ඒ blah 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 කියනවා. හරි. Okay. Now this is the definition. This is the definition. Pute, if the ratio between two physical quantity, if the ratio means x over y or y over x, that is the ratio. If the ratio of two physical quantity, if the ratio of two physical quantity is a constant, that two physical quantities are said to be in directly proportionality. In a directly proportional case, if the ratio between two physical quantity is a constant, ratio should be a constant. अब सिंगल केला मेरा अनुलोम है केला अनुलोम समानुपाती का केला अनुलोम है अनु केला क्या है पुते अनुपात है ratio. Okay, ratio. So if the ratio is a constant, that means it is a directly proportionality. Ratio should be a constant. Okay, it's a constant. Look at this one. Look at this one. What is the ratio? Ratio is 4 over 1. The ratio 5 over 2. The ratio 6 over 3. Are they equal? Are they equal? Are they equal?
No.
No, therefore this is not a directly proportionality. In this case, x and y are not in directly proportionality. Look at this one. Look at this one. X over y or y over x. Up again y over x. So if I take y over x, so what is the answer? In this case, 2. In this case, 4 over 2, that is 2. In this case, 6 over 3, that is 2. Look at this one. In every case, the ratio is equal to 2. That means the ratio is a constant. Ratio is a constant. Therefore, this one is a directly proportional case. This case is a directly proportional case, but this one is not. This one is not. தெரியும்.
Yes, sir.
Right. That's why when x increases, when x increases, y also increases, but in the same ratio. Ratio should be equal. Then tell me, what is the definition of indirect proportionality? What is the definition of indirectly proportionality? Can anyone guess?
The ratio is not constant.
Ratio is not constant, but it is not a definition of it. Can anyone guess?
If the x ratios decrease by one value, the y ratio also should be decreased by another. That's not right. Okay.
බලන්න. In this case, ratio should be a constant, Pute, but indirect proportionality, the product should be a constant. Product x into y should be a constant. X into y should be a constant. X into y should be a constant. Look at this one. X into y means 3. X into y means 4. X into y means 3. Therefore, the x into y is not constant in this case. But look at this case. In every scenario, x into y is equal to 50. X is y is equal to 50. X into y is equal to 50. මේක නිසා තමයි ඕගොල්ලෝ calculate කරේ direct proportion ඉන්නේ මේක use කරලා තමයි ඕගොල්ලෝ calculate කරේ. දන්නේ නැහැ නේද? හරි. So if two physical quantities are indirectly proportional, that means the product should be a constant. If they are directly proportional, the ratio should be a constant. Did you get my point? තේරුණාද?
Yes.
Yes,
And that is the definition. That is the definition. හරිද පුතේ? එහෙනම් so before we discussing about the relationships, that means before we build a formula, we have to get an understanding about relationships between two physical quantities. There are two kinds of relationships. One is directly proportionality, other one is indirectly proportionality. Okay, those are some specific relationships with it. Those are some specific relationships. And so we have to get an understanding about directly proportionality as well as indirectly proportionality. Write down that thing. මට හැමෝගෙම පොඩ්ඩක් රෙස්පොන්ඩ් එකක් දෙන්න පුතේ. දැන් මේ ළමයි ගොඩක් ඉන්නවා. හැමෝම මට ආන්සර් එකක් දෙන්න. තේරුණාද? Did you get my point? Or if you need any further clarification, tell me. Did you get my point?
yes, sir.
Thank you.
Yes, sir.
Thank you, Vijay. Thank you. Thank you, Vijay. මෙයා පුතේ මේ ගොඩක් මේක අත්ත කතන්දරේ ඕගොල්ලෝ විතරක් නෙවෙයි ගොඩක් දැනති කට්ටිය මේකේ ඉන්නවා. මම කියා දෙන්නම් ගොඩක් වෙලාවට මේ ඒලවලදී කරන ලොකු වැරද්දක් කියා දෙන්නම්. ඒක ඕගොල්ලෝ ඉස්සරහා කාලේදී ඕගොල්ලන්ට ඉගෙන ගන්න දහුයි. ඒක ගන්න වැරද්ද. හරි. මම ඒක කියනවා. හරි. ඒක තමයි පුතේ මේ සාමාන්‍යයෙන් normally we can represent directly proportional. Directly proportional is represented as this symbol. This is the symbol of directly proportionality. නිකන් අර මාළුවෙක්ගේ අර පස්සපැත්තේදී මාළුවෙක් වගේ. හරි. So this is the symbol of directly proportionality. So if there is this kind of symbol, that means x directly proportional to y. X directly proportional to y. Okay. So if x directly proportional to y, so this is the relationship. So using this relationship, I can build an equation. How to do that? Using their definition. So if x directly proportional to y, that means the ratio x over y ratio should be a constant. K is a constant. K is the symbol of constant. Constant. So if I write K, that means it is a constant. So this one is a constant. So if I subject x, x is equal to ky, no? F is equal to ky. Are you clear?
Yes,
F
sir.
is equal to ky. So if you are given this kind of relationship, that means x directly proportional to y, then I can convert this relationship. I can convert this relationship into an equation x equal ky. X equal ky. And actually, I have used this. We use this definition only. I have used this definition. So using this definition, I have convert this equation convert this relationship into an equation. The same thing can be done for indirect equation, indirectly proportionality. Normally, indirectly proportionality symbolically represent in this way. So if there are this kind of symbol, that means x is indirectly proportional to y. Indirectly proportional to y. So according to the definition of indirectly proportionality, if x indirectly proportional to y, that means the product, that means x into y. X into y is a constant. F into y is a constant. That means if I subject x, x is equal k into 1 over y. K into 1 over y. Did you get my point?
Yes.
That means if you have this kind of relationship, I can convert that relationship into an equation x equal k 1 over y. හරිද? දැන් මෙහෙම දෙයක් ඕගොල්ලන්ට අනිවාර්යෙන් අහුවෙයි ඉස්සරහට. මේ ඩෙෆිනිෂන් එක දන්නේ නැතුව කවුරු හරි කියා දෙනවා නම් අනිවාර්යෙන් බලන්න ගොඩක් කට්ටිය මේක බලන්නේ මෙන්න මේ විදිහට. මේ වගේ සිම්බල් එකක් තිබ්බොත් ඒ සිම්බල් එක ඉක්වේෂන් එකක් කරන්න නම් සමානයි k දැම්මම හරි. සමානයි k දැම්මම හරි කියලා ඔන්න කියනවා. හරිද? ප්‍රොපෝර්ෂනල් සිම්බල් එක තිබ්බහම මේක ඉක්වේෂන් එකක් කරන්න සමානයි k දැම්මම හරි කියලා කියනවා. මොකද්ද පුතේ ලොජික් එකක්ද ඒක? ඒව ලොජික් නෙමෙයි. අපි අනිවාර්යෙන් හරි තරකේ තේරුම් ගන්න. හරි ලොජික් එක ගන්නවා. අනිවාර්යෙන් මේක තියෙනවා. හරි. ඕගොල්ලන් අනිවාර්යෙන් ඇහෙයි මේ වගේ දෙයක් අනිවාර්යෙන් ඇහෙයි. හරි. අනිවාර්යෙන් මේ සිම්බල් එක අයි මේක දිහා බලුවා මේක දිහා බලුවා. මේක දිහා බැලුවා. හරි. මාළු අයින් වෙන්න නම් අනිවාර්යෙන් ඉක්වල් කේ දාන්න ඕනේ. අන්න හදාගත්තා හරි මාළු අයින් කරන්න ඉක්වල් කේ දාන්න ඕනේ. මතක තියාගත්ත ගමන් නෑ නමුත් ඒ වුණාට there is not a definition නේ. මේක definition එකක් නෙමෙයි. ඔය වගේ දේවල් ගොඩක් තියෙනවා. අපි හරි definition එකට යන්න ඕනේ මොකද otherwise we cannot understand other thing. හරිද? මේකෙන් ඊට පස්සේ අපිට එනවා මේවා graph අදින්න එනවා. මේවා graph අදින්න එනවා. ඊට පස්සේ graph බලලා අපිට relationship form කරන්න එනවා. දැන් මේ වගේ තැන්වලදී අපි හරි understanding එක තියෙන්න ඕනේ. මොකක්ද මේ කිව්වේ කියලා. හරිද? මේ එකක් හොඳේ මේ වගේ තව ගොඩක් තියෙන කන්දර ඒ නිසා හොඳ වෙලාවට හොඳට මතක තියාගන්න කටපාඩම් කරන්න යන්න එපා. Please understand the basic. But if you can understand the basic, then you can memorize that thing as you wish, okay? But the thing is, you have to understand the basic. Once you understand the basic, then you can memorize as you wish. And ඔය දන්න අනිවාර්යව ඔය කතන්දර කියනිත් දන්න අනිවාර්යව ඔක තමයි කියන්නේ. හරිද? ගොඩක් කියන්නේ 90ක් තැන්වල ඔය තමයි උදේ කියන්නේ. සමානුපාතික ලකුණු අයින් අපි වෙන්නේ කියන්නේ සිංහල සමානුපාතික ලකුණු කියනවා. සමානුපාතික ලකුණු අයින් කරන්න සමානයි k දාන්න පුතේ කියලා කියනවා. හරි. එහෙම තමයි හරි කියලා කියනවා. ඒක නිසා මේ ඔය එකක් මේ පුංචි දෙයක් නේ. ඔය වගේ දාපුත්තේ ඉස්සරහට තියෙන ගොඩක් ගැඹුරු තියරි පාර්ට් කියන්නේ තොමම තමයි. නැත්තම් ඉතින් 140 ෆේල් වෙන්නේ නැහැ. කතන්දර ඒකද 140ක් ඔයගොල්ලන් ෆේල්. දැන් ඕරවල එනි ස්පීඩ් එකකින් 140ක්ම ෆේල් වෙන්න හේතුව ඔක තමයි. හරි. ඊට පස්සේ මේව කටපාඩම් ගියන් කියලා කොහොමද පුතේ ඇප්ලයි කරන්නේ? ඇප්ලයි කරන්න අමාරු තමයි. හරි. අපිට ඇප්ලයි කරන්න අමාරු. දැන් ඕගොල්ලෝ දැන් මේ අමාරුම පේපර් එකටත් හොඳ මාක්ස් ගත්තානේ. ඒ කියන්නේ ඕගොල්ලෝ ඇප්ලයි කරනවනේ. හරි. අන්න ඒකයි තේරුම් ගන්න ඕනේ. හරි. ඇප්ලයි කරන්න ලේසි වෙන්න නම් අනිවාර්යෙන් හරි ආගියුමන්ට් එක ඔයගොල්ලෝ ඔලි තියෙන්න. හරි ආගියුමන්ට් එක ඔයගොල්ලන්ගේ ඔළුවේ නැතුව ඇප්ලයි කරන්න බෑ කොච්චරද. ඇත්ත කතන්දර මේක. හරි. ඕකේ. We can write that thing today. අපි ඒක ලියගමු. Okay. There are two main. No, but no, it is not alpha. It is not alpha. It is not alpha. It is something equal to alpha. The symbol is equal to alpha, but it is not alpha. It is a symbol of proportionality. Proportionality symbol. අපි කියන්නේ ඒකට proportionality symbol කියලා. Okay, write down under this topic. There are two main relationships. There are two main relationships between two variables. Between two variables. Between two variables. පුංචි ඔයගොල්ලන්ට ක්වෙස්චන් එක මම දෙන්නම් පොඩ්ඩක් තනියෙන් හිතන්න. Okay? You know about Newton's law, no? There are three Newton's law, no? There are three laws, no? I know you have done that in your orders. But actually, there should be only one Newton law. All the Newton's laws can be described or can be derived using one single equation. Can you explain that thing? Can you explain? There's no need to have three laws. All the laws can be explained by one law. And that is the second law. Therefore, the only thing you have to understand the second law, you can derive all the two laws, all the other laws using Newton's second law. Now you have time. Try to prove that part. Try කරලා බලන්න. ආසීති. හරිද? ඒක හොඳයි පුතේ. ඒක ඔයගොල්ලන්ගේ ඔළුව ටත් හොඳයි. ඔය කාලේ ඔය මටත් දුන්න මේ එක්සර්සයිස් එකක් නේද? මටත් අපේ මැත්ස් එක දුන්නේ. ඒ දවස්වල හරි මාත් ඔය පාක් කරලා ලෙඩලම හොස්පිටල් එකේ ගිහින් දවසක ඔය මගේ ඒ ලෙඩ අහන්න කතා කරලා සර් කොහොම කතා කරලා ඔන්න ඔකක් දුන්නා. හරිද? ඊට පස්සේ කොහොමද මම හදාගත්තා වැඩි අන්තිමට ඉතින් ඒ හදාගත්තට පස්සේ අපිට පොඩි මේකක් තියෙනවා තාමත් මට මතකයි ඒකයි මම තනියම හදපු නිසා මොකද්ද නිව්ටන්ස් ලෝස් තුනම අපිට නිව්ටන්ස් සෙකන්ඩ් ලෝගේ මේ ප්‍රූව් කරන්න පුළුවන් පුතේ නිව්ටන්ස් සෙකන්ඩ් ලෝගෙන් ප්‍රූව් කරන්න පුළුවන් හරි try කරලා පුළුවන් නම් මේ ප්‍රූව් කරන්න බාර ලස්සනයි වැඩි හරි okay okay අපි මොකක්ද ලියාගත්තේ අන්තිමට පුතේ there are two relationships in between two variables. Can anyone repeat that one? The last sentence.
There are two main relationships between two variables.
Thank you. And then the first subtopic, direct proportionality. Direct proportionality. Write down on this. If the ratio, if the ratio between two variables, if the ratio between two variables, if the ratio between two variables is a constant, is a constant, is a constant. Is a constant. Is a constant. Then the two variables, then the two variables, then the two variables are directly proportional to each other. Are directly proportional to each other. It's fine. Okay. X 1, 2, 3, y 4, 8, 12. Then y over x. Y over x means 4 over 1. 4 over 1 is 4. Then 8 over 2. 8 over 2 is again 4. Then 12 over 3. Again is 4. Again is 4. Therefore, you can clearly see in this case x over y. X over y is a constant. It is a constant. It is a constant. It's a constant. Therefore, x over y over x is a constant. Okay. Actually, when x over y is a constant, it is very clear. When x increases, y also increases. That is a characteristic. That is a characteristic, but that is not a definition. Okay, that is a characteristic of a directly proportionality. When x increases, y also increases by the same ratio. Yeah? So that is the characteristic. But the definition is x over y should be the constant. Okay, write this one. Write down this one. Okay. Very good. Anita, have you completed it? Have you completed?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Then write down under this. Write down under this. This can be symbolically represented. This can be symbolically this can be symbolically represented. This can be symbolically represented as x when they have it. X with the x when it says f directly proportional to y. If so, this is the format of representation of the relationship. So this is the format of representation of the relationship. The relationship okay. So if you are given this kind of relationship, that means x over y is a constant. That means I can subject x. That means x means k into y. So I can write this one. So if I gave this kind of relationship, then I can write x equal k into y. F equal k into y. F equal k into y. That means if you are given a relationship, like this, you can convert this relationship into an equation. Because actually, if you are given a relationship, you cannot do any mathematical operation for relationship. You cannot do any mathematical operation for a relationship. This is just a relationship. Okay. So if you are given a relationship, you have to convert it into an equation. Then only you can do some calculation. That's why we have to convert this one into an equation. So if you are given this kind of relationship, then I can write this one. Then I can convert this one into an equation using the definition. That means x equal k into y. Therefore, this one is the representation of the relationship. This one is the equation of the relationship. So this one of the relationship so this is the representation of the relationship. So this one is the equation for the relationship. Equation for the relationship. Write down this one. Okay. Haribe.
Yeah, sir.
Done, sir.
Okay, thank you. Uday. Yes, Puti. You are right, Himanshu. Okay, Uday. Marlon Mema, look at this one. Suppose if y is directly proportional to x, if y is directly proportional to x, then I can write that one is y equal kx. Y equal x. Okay. That means, Malanna, can you remember a graph pattern? This kind of graph pattern. Graph pattern matak kena. This is equal to y equal mx, no? M is a gradient. M is gradient, yes. Y equal mx. M is gradient, no? M is gradient, gradient is a constant. Therefore, this is equal to y equal mx pattern. Y equal mx pattern. In this case, m is the constant. Constant is the gradient. This is the constant. This is the constant. Therefore, that means the graph between these two parameters, the graph between these two variables, that means x and y, should be a straight line. Should be a straight line that goes through the origin. That goes through the origin. Did you get my point? So if there is a graph that goes through the origin, that means these two variables are in directly proportionality. Did you get my point?
Yes, sir.
That means this is the representation of graphical representation of two directly proportional variables. So this one, graphical representation of directly proportional proportionality. Like the line. This one is 0, 0. V equal IR, we cannot get that to the, we can get that if IO R is a constant. Constant when R is a constant, V directly proportional to Y. When resistance is constant, then V is directly proportional to Y. That's okay.
Done, sir.
Okay. Shall I erase? Shall I erase? Okay. Then write another subtopic, indirectly proportionality. Indirectly proportionality. Indirectly proportionality. Indirectly proportionality. And know that. Write down on that. Write down on that. If the product of two variables, if the product of two variables if the product of two variables is a constant, is a constant, is a constant, then the two variables, then the two variables, then the two variables then the two variables are indirectly proportional to each other. Indirectly proportional to each other. Indirectly proportional to each other. This can be symbolically represented. This can be symbolically represented this can be symbolically represented x indirectly proportional what? अब example अब लगाऊं x y x 5 10 10 5 25 to 25. එකපාර ටිකව ලැප් එකේ මේ Wi-Fi එක එයා එහෙම රියැක්ටිවේට් කරගන්න. එකපාර ඩෝන් ගාලා ඉතින් ඉන්ටර්නෙට් ගියා මේ මොකද ළඟදී වෙන දවස් දෙක තුනක් වුණා. එකපාරට Wi-Fi ඩිලීට් කරගන්න එක ටික වෙලාවක් ගියාට පස්සේ ටිකක් අර ක්ලාස් එක දිගටම කරගෙන යද්දි නැති වෙනවා. මම බලන්න පොඩ්ඩක්. හරි. Okay. Record this. This size 50, 50, 50. You can write down this one. Done. Once you complete it, please let me know.
Done, sir.
Thank you, Bhute. Then I can write this one as a symbol. Symbolically, I can represent this one, Bhute. X indirectly proportional to Y. Okay. Normally we call this one as X indirectly proportional to Y. Indirectly proportional to Y. The same symbol. Okay. Same symbol. Then using the definition, I can write the product of X and Y. The product of X and Y is a constant. Is a constant. That means if I subject X, X is equal to K into 1 over Y. K into 1 over Y. So I can write this one under this. So if X is indirectly proportional to Y, that means X equal K into 1 over. So this means, so this is the relationship. This is the relationship between X and Y. This is the equation derived using that relationship. So how did I derive that one? Using the definition. Using definition of that relationship. X into Y is equal to K. X into Y is equal to K. Okay. That means if you are given this kind of relationship, that means it can be converted into a equation like this. So this is totally based on the definition of indirectly proportionality. This is totally based on the definition of the indirect proportionality. Therefore, this one is the representation of the relationship. This one represents the equation, or this one is the equation of the relationship. So, this is the representation of the relationship this one is the equation of the relationship. Equation of the relationship. Okay. Write down this thing. Can anyone guess the graph? Can anyone guess the graph between x and 1? Can anyone guess the graph? Look at this one.
Sir,
Yeah.
it will have a smooth curve, right?
It should be a curve.
Okay.
Okay, it should be a curve. Okay, one. Now, if y is indirectly proportional to x, if y is indirectly proportional to x, then I can write the equation is equal to x. Okay, you can clearly see this is not a straight line. This cannot be a straight line. If it is a straight line, definitely it should be y equal mx plus c. Y equal mx plus c. Right? But the thing is now the y is equal 1 over x. 1 over x. Therefore, definitely this is not a straight line. And actually, look at this one. Now, I can draw y and x axis here. Suppose x goes to, suppose when x goes to 0, when x goes to 0, what will happen? X is 0 y goes to 1 over 0. 1 over 0 is a constant. Y goes to 1 over 0. When x goes to 0, y goes to 1 over 0. Is that clear?
Yes, sir.
Yes.
Is that clear? Yeah, I just replace x by 0. Correct? 1 over 0 means how much? 1 over 0? 1 over 0? 1 over 0?
Infinity.
Huh?
Infinity.
Yes, it is infinity. It is infinity. Normally, in mathematics, we cannot define the division of 0. We cannot define that thing. But we can assume that one is very huge number. Very huge number. That means suppose now there's a pen. So if you want to divide this pen into 2 equal parts, that means you have to divide this pen into two equal parts. No? If you want to divide this pen by 4, that means you have to divide this pen. You have to separate this pen into 4 equal parts. If you divide this pen into 10, that means you have to divide this pen. You have to separate this pen into 10 equal parts. If you want to divide this pen by 0, then you have to separate this into 0 parts. Is it? So now I remove 0, 1, put here. Again 0, 1, put here. Again 0, 1, keep it here. Again 0, 1, keep it here. Can I complete that one? No. I cannot even I cannot see a 0 portion. Therefore, I cannot complete my division. So that might be very huge number. Mathematically, it doesn't have a definition. We cannot define. We cannot define. But 1 over 0 should have very huge value. Should have very huge value. Therefore, in physics, normally for convenient calculation, normally we consider it as infinity. It has infinity. Therefore, 1 over 0 means infinity. Infinity. It goes to infinity. Normally we call it as this one. It goes to infinity. Not equal to infinity. It goes to infinity. And it goes to infinity. That's why I use this arrow symbol. X goes to 0. When x goes to 0, y goes to 1 over 0. Goes to. And 1 over 0 means it goes to infinity. This is a symbol of infinity. Alpha නෙවේ අර අටේ ඉලක්කම අනිත් පැත්තට ගුවාවි. And it goes to infinity. Therefore, when x goes to 0, y goes to infinity. Infinity. Y goes to infinity. Y goes to infinity. Then, when x goes to infinity, f goes to plus infinity, then y goes to 1 over infinity. 1 over infinity. What is the value of 1 over infinity? Did you get my point? When x goes to infinity, x goes to infinity means over there. May පැත්තට x. When x goes to infinity, 0, 10, 100, 1000, 10,000, x goes to infinity. When x goes infinity, that means y goes to 1 over infinity. So what is the value of 1 over infinity?
0.
Yes, very good. It will be 0. It will be 0. Yeah, you can clearly understand this one. What is the value of 1 over 10? 0.1. 1 over 100? 0.01. 1 over 10 to the power 10. That means 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 1. 10 to the power 10 means it is almost 0, no? So, if it is infinity, then it will become 0.000000000. It almost equal to 0. It almost equal to 0. Therefore, when y goes to 1 over infinity, it goes to 0. Goes to 0. Therefore, when x goes to infinity, y goes to 0. Therefore, we will have this kind of curve with a, we will have this kind of curvature. We will have this kind of curvature. We will have this kind of curvature. So the relationship is y indirectly proportional to x. Normally we call this as rectangular parabola. This shape is called as rectangular parabola. Rectangular parabolic shape. Rectangular parabolic shape. ත්‍රිකෝණාස්ත බහුවලයක් කියලා කියනවා. Okay. මේක තමයි.
Done, sir.
Okay. Have a good day.
Done, sir.
Thank you.
Done, sir.
Okay. The right topic. The right topic. Building a formula. Building a formula. Building a formula. Formula. Between two variables, between two physical quantities, between two physical quantities. Between two physical quantities. Between two physical quantities. I will make an example like in column. We can do this one using an example. This is the example. Write down this example. Suppose capital A is the area, capital A is the area of a square, of a square. Of a square. and simple b is the length of a side. Simple b is the length of a side of this square. And simple b is the length of a side of this square. Build a formula between these two variables, between these two physical quantities, these two physical quantities. Now it is given A. Capital A is the area of a square. So this is the A. And side length is B. B is the side length. Suppose you don't know about the equation. Okay. Suppose you do not know about the equation. A is the area, B is the side length. Now we are going to derive a formula. To represent the relationship between these two physical quantities. Okay. How to do that? But there's a very, very interesting argument. Look at this. Everyone, please look at me, and please listen to this very carefully. So this is the argument. In this case, I'm going to do an assumption. First. What is the assumption? I'm going to before this one, I have to say another thing, very small thing. And then okay. I have to say very little, not an argument, but it is a very little thing before that. I know when x is indirectly proportional to y, it can be represented as x over x indirectly proportional to 1 over y. Is proportional to 1 over. So actually it can be written as this one, x directly proportional to 1 over y to the power minus 1. 1 over y means y to the power minus 1. Therefore, indirectly proportionality can also be represented as a directly proportionality. But the thing is, the power should be minus 1. That's all. Did you get my point?
Yes.
Yes, sir.
කලින් කොහේ හරි තැනක ඉඳ තියෙනවා නම් පොඩ්ඩක් මේක දාගන්නවා. දැන් මේ don't write this one under this topic. If you have enough space under the previous lesson, can you put this one? X directly proportional to 1 over y. It can be written as this one. Therefore, x directly proportional y to the power minus 1. Y to the power minus 1. Y to the power minus 1. If you have enough space in previous under the previous one, please write this one. That's all.
Done, sir.
Okay, thank you. Okay, thank you. That means any relationship can be written as a derivative proportional. No, that is the point that I have that I need doing. Okay, everyone come to the discussion. Now, there's a square. The area of this square is A. The side length is B. Now I'm going to build a relationship between, actually this build a formula between A and simple B. So in this case, the first thing I have to do, I'm going to do an assumption. No assumption. So what is that assumption? I'm going to assume the area is directly proportional to b to the power x. B to the power x. X may be any number. X may be any number. And x may be 2, 1, minus 1. X may be any number. Minus half, plus half. Therefore, I can write any relationship using a proportionality symbol. Okay. Therefore, A is directly proportional B to the power some power. B to the power x. I don't know that one. My calculation should be the find in x. So that is the assumption. What I have assumed, I assume the area is directly proportional b to the power x. I don't know the value of x. I know the value of the x, but I'm going to calculate that one. How to calculate? So this is the assumption part. Number one is the assumption. Using the assumption, I have write a relationship. So using a relationship, I cannot do anything. So I have to convert this relationship into an equation. How to convert this into an equation? If they are directly proportional, I can write this one as A is equal K dx. K dx. You have right. What is K? K is a constant. K is a constant. K is a constant. And okay, suppose you know all about K. If you know the dimension of K, if you know the dimension of K, if you know the dimension of B, and if you know the dimension of A, then you can apply all the dimensions into this formula, and you can determine the value of x. value of x. Did you get my point? Hmm?
Yes, sir.
But the thing is, there are limitations. There are limitations. What are those limitations? I have to aware about A, K, and B. No, I have to aware about A, K, and B. Otherwise, I cannot calculate x. Ne? Therefore, I should know the dimension of A. I should know the dimension of K as well as B. If I know them, then I can determine the x. So this is an analysis that have so many limitations. Many limitations got okay. We can do this calculation if we are given this information. Otherwise, we cannot do this. Okay. Okay, you can write this one. A is area, B is side length, and you can draw this one. You can draw this one. Don't write these two. Don't write these two steps. Don't write these two steps. No. I'm not going to determine the dimension of x. It is a number. It is a number. I'm going to find that number. Okay. I'm going to find that number. Okay.
Okay, sir.
Okay. Write down on this. Write down on this. In this case, the following steps. The following steps. In this case, the following steps. Will be used in this case, the following steps will be used. Here number one, number one. Let assume the area is directly proportional. The area is directly proportional to b to the power x. To b to the power x. To b to the power x. Now you can write this one. Okay. Now you can write this one. This one only. Then the second one. Don't write this one. Then the second step. Convert the above relationship. Convert the above relationship into an equation. Into an equation. Okay, write down this one. Write down this one. Okay. Write the third one. Third step. Third step. If the dimensions of if the dimensions of A, comma K and B, A, K and B A, K and B are known, we can find the value of X. We can find the value of X. Therefore, if we know the values of K and X, if we know the values of K and X, if we know the values of K and X, then we can determine the formula. We can determine the formula between these physical quantities. We can determine the formula between these physical quantities. Look at this one, Bhute. So this is the assumed equation, Bhute. This is the assumed equation. So if you know the value of K and if you know the value of X, then we can write the equation, no? The only thing I have to determine is K and X. The problem is I cannot determine K. It should be given. It should be given. If it is given, then I can determine X. Okay. හරිද K value එක මට හොයාගන්න බෑ. ඒක මට අනිවාර්යෙන් දෙන්නම ඕන. If it is given, then I can determine the equation. හරිද? Okay. එහෙනම් අපි මේ question එක හදමු. Suppose the K value is equal to 1. Suppose the K value is equal to 1. Let's do the equation. Let's build this equation. Now, A is equal K dx. So if k is equal to 1, I can write the area is equal b to the power x, because k is equal 1. Now A is area, no puta. A is area. Therefore, I know the dimension of the area. This is area. This is an area. Therefore, I know the dimension of area. Dimension of area. What is the dimension of area? Again?
L square.
Yeah, L square. This one is L square. Is equal B. What is B? B? Yes, it is a length. B is a length. This is a length. This is a length. Length means the dimension is equal to L. Therefore, this is L to the power X. So, look at this one. So, this is a form equation. This is an equation. So, an equation, the power of equal bases, the power of same base, the power of same base should be equal. The powers of same base, the powers of same base should be equal. So I can equate the powers of same base. Take the argument, what is the argument? Equating powers of same base. That means if there are two wells, there should be two wells. No. If there are four wells, then the right hand side should have four wells. If the left hand side may have two M's, the right hand side should have two M's. Okay, likewise, the powers of same base should be equal in an equation. So according to that logic, x should be equal to 2. X should be equal to, then I can rearrange the formula. Therefore, A should be equal. Now, K is 1, no? B should be simple B square. Therefore, A should be equal to B square. Did you get my point? There you
Yes.
Yes, sir.
logic. The first logic is the assumption. I have assumed the given two physical quantities have a directly proportionality. But I don't know about the power. I can assume whatever the power. Okay. Then I have converted the relationship into an equation. After that, if I am given the proportionality constant, then I can find the value of x. මට අර අතන පුතේ පොඩි නමක් කියන්න බැරුණා proportionality constant කියන නම මට දැන් ඔය කියවිච්ච මම කියන්නේ k is called as proportionality constant. Initially we have mentioned that k value ඕන්න මෙතන k ගාව දාගන්න relative proportionality එකයි indirect proportionality එකයි ගාව k, okay, it is a proportionality constant. Okay. You can write there when you are doing derivative proportionality and indirect proportionality, we have used this K value. Normally K is called as proportionality constant. Proportionality constant. K is proportionality constant. මෙතන ලිව්වොත් ඉතින් කමක් නැහැ ඉතින් ආයෙ අර හුවෙන මතක් වෙනවා. හරිද?
Done, sir.
Done, sir.
Okay, then write down this example. This is a homework. This is homework. Suppose the volume of a cube, the volume of a cube volume of a cube is represented by capital B, is represented by capital B. Simple B is the side length of the cube. Simple B is the side length of the cube. Simple B is the side length of the cube. Side length of the cube. Build a relationship between A and simple B. Sorry, build a relationship between V and B. V and B. Build a relationship between B and V. So that is a homework, and that's another homework.
Sir, build a relationship between what's the
Build a relationship between V, capital V and B. V and B. V and B. So that is one homework. Another one is do the first 30 question. do the first 35 question. Do the first 35 MCQs. Don't go beyond 35. No. Relationship means a formula, Pute. It should be a formula. And relationship should be a formula. And within the brackets, within the brackets, we have to put should be the formula. Not only the
Sir,
relationship. Yeah.
should we do the MCQ by doing the workings as well as the,
Sorry, Pute?
should we do the MCQ by doing the workings in the paper or just?
No. That's why now I'm explaining that thing. Now I am explaining that thing. You have to do first 30 MCQs. Now you have to do first 30 MCQs. Yeah, there is a method of doing MCQs. There's a method of doing MCQs. I don't know how are going to do the tute. Some students normally, some students do tute in some A4 sheets or some of sheets. Then they will attach the sheets to the paper, the sheet to the tute. And එහෙම කරන්නත් පුළුවන් නැත්නම් ඔයගොල්ලන් මොකක් හරි පොතක් තියාගන්නත් පුළුවන්. හරිද? පොතක් තියාගන්නත් පුළුවන්. But the thing is you have to have that answer sheet with the tute. Tute එකත් එක්ක answer sheet එක තියාගන්න. ඔයගොල්ලෝ ඒ පිළිවෙල හදාගන්න. මට කියන්න බෑ. ඉතින් ඔයගොල්ලෝ එක එක්කෙනාගේ පිළිවෙල වෙනස්. හැබැයි tute එක ගත්ත ගමන් answer sheet එක හොයාගන්න පුළුවන් විදිහට තියාගන්න. හරිද? ඒ නිසා answer sheet එක it may be a book. It may be a book or it may be some rough sheet. It is no issue. Because this is a tube. This is a tube. But for papers, I need a book. For papers, I need a book. So this is a tube. Therefore, you can have a small book or some A4 sheets or some rough paper sheets. The rough paper sheet means there are some exam papers only. Exam papers or papers theory. They will follow the and ඒ වගේ papers use කරන්න පුළුවන්. හරිද? use කළා මේක දාන්න පුළුවන්. ඒක ප්‍රශ්නයක් නැහැ. හරිද? The important thing is you have to complete this 30 questions. You have to complete these 30 questions within 1 hour. Write down this thing. Within 1 hour. Within 1 hour. And you have to complete that thing. If you complete this 30 questions less than 1 hour, please note down that thing. Please note down that thing. Suppose you have completed that thing, you have completed the 30 question within 45 minutes, you have to mention. I just may spend 45 minutes up to this. Anyway, you have to monitor the time. Anyway, you have to monitor the timetable. If anyone consume more than 1 hour, that should be also noted. ඒක අනිවාර්ය noted වෙන්න ඕනේ. හරි. මේක අනිවාර්ය noted වෙන්න ඕනේ. That should be noted. And the most important thing is you have to monitor how many questions you did within that 1 hour. How many questions you did within that 1 hour. Okay. Then you can mark your answers. Then you can mark the answers. Okay. After that, you can complete the rest of questions. And after that, you can complete the rest of questions. But don't take more than 1 hour. Don't take more than 1 hour. Within 1 hour, you have to complete that thing. If you are consuming more than that time, don't go beyond that time. You stop the work and mark all the questions. Then do the rest of things. And ඒකයි කරන්න ඕනේ. කියන්නේ මුලින්ම යන්න එපා එතනින් එහාට. Okay, පුතේ. Sorry for that plan. Sorry for that plan. That is my fault. ඒ කියන්නේ අතර මට මේ දවස් ටිකක් නෙවෙයි අතර හොඳට බිසි වෙලා හිටියේ. මොකද මොකක්වත් කරන්න ඕනේ නැහැ. අතරම මේ ඒ කියන්නේ අපි දැන් මේ ලොකේෂන් එක පොඩ්ඩක් shift කරන්න යන්නේ. ඒකත් එක පොඩ්ඩක් බිසි වෙලා හිටියේ. මට මේ week එක පොඩ්ඩක් මට බිසි වෙයි. මේ week එකේ පොඩ්ඩක් ඕගොල්ලෝ PDF එකෙන් පොඩ්ඩක් බලා ගන්න පුතේ. මම PDF එක වන්නම් අය පාරක්. Next week මම definitely ගිහිල්ලා මේක post කරන්න මට ටිකක් මේ ටිකක් ඒ කියන්නේ class ටික වුණාට පස්සේ there's no time. That's the problem. යාද උදේත් 5 ඉඳන් දැන් 10 මාර නිකම්ම class තියෙනවා. ඒ නිසා දැන් ආයෙසලා ඒ වගේ තව දිගටම schedule එක. මේ මට මේ week එක පොඩ්ඩක් මේ week එක නම් පොඩ්ඩක් busy වෙයි. After this week I will send the hard copies. Until then please use the PDF. Sorry for that, okay? I apologize for that, okay? Okay. Then the next thing is normally we are going to discuss each and every questions with it. That means I will give my review. How I get that answer. If it is different with your way, you have to mention that thing. Okay. Therefore, you have to write my review too. And නිසා මතක තියාගන්න මේකට review එකක් තෝරන්න. Remember that thing. You have to do a review for this one too. Otherwise, no meaning of doing MCQ questions. So the first thing is do the questions within 1 hour. Do not worry about the calculation. Just do the questions. And if you can get the answers within your mind, go for that one. Okay, don't worry about calculations. Just complete all the questions within 1 hour. Okay. Then you can write your review. Review means the argument, just only the argument. Don't do any calculation, don't do any simplification within that review. Review ekadi simplification එකක් ඕනේ නැහැ. Just write the argument. This is the argument. Only the argument. Because you have to aware about the argument very well. අනිවාර්යෙන් ආගියුමන්ට් එක හරියටම දැනගෙන ඉන්න ඕනේ. එහෙම නැත්නම් භාගයට කළ වැඩක් නෑ MCQ. ඒ නිසා මුලින්ම කරන්න ඕනේ MCQs 30 questions එක හුස්මකට කරලා දාන්න. After that you have to write a review. For first 30 question. And for first 30 question, if you can use a book, a small book, it might be better. Or if you can, you can prepare a booklet. It also may okay. I don't worry about that thing. That is up to you. But the thing is, you have to maintain the answer sheets as well as the review sheets. Okay. Therefore, please make sure that there are no need to worry about my review sheets and your review sheets. If there is any different, you can note down in the same place, at the same place. Okay. එකම දාලා කියලා දාන්න. ඉතින් වාගේ රිවිව් එක මගේ රිවිව් එක පෑන් දෙකකින් ලියන්න. It's okay. හරි. Okay. I think do you have any questions? Do you have any questions regarding the way of doing MCQs? Questions?
No, sir.
No. Okay. Okay, Pute. Then we can complete today's class. So everyone, okay. Good night, everyone. Have a nice week.
Bye, sir. Thank you.
Bye.
Bye, bro.
Bye.